Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 2 exam for October-November 2022 variant 2. So let's get started. Question 1 says which measuring devices are most suitable to determine the volume of about 200 milliliters of liquid and the diameter of a thin wire. So 200 milliliters of liquid we can use a measuring cylinder, and for the small diameter we use the most accurate device we have in the syllabus, which is a micrometer. So the answer is A. Question 2 says the diagrams show speed time graphs for 4 different bodies moving for 6 seconds. Which body traveled the least distance? So we need to calculate the areas under the graphs. Here we have a triangle. We multiply half by the base, which is 6, by the height, which is 8. That gives us 24. And the next one we have two triangles, so we need to do that calculation twice. Half multiplied by 4 multiplied by 8 plus half multiplied by 2 multiplied by 4. The total here is 20. The next one is a rectangle, so we multiplied length by width. 8 multiplied by 6, that gives an answer of 48. Here we have two rectangles. The bottom one is 6 multiplied by 4. The top one is 4 multiplied by 4. So we have a total here of 40. So the smallest distance would be for B. Question 3 says which statement describes the relationship between mass and weight? Mass is the effect of gravity. No, mass is a property in matter in general, not affected by gravity. Mass is the effect of a magnetic field. No, weight is the effect of gravity. That's actually correct due to mass. Weight is the effect of a magnetic field. No, so the answer is C. Question 4 says the diagram shows 4 pieces of a laboratory apparatus. Which pieces of apparatus are used to find the density of a liquid? So we need the balance for mass and we need the measuring cylinder for volume of a liquid. So the answer would be B. Question 5 says the diagram shows a meter rule MN on two supports P and Q. Two loads are placed on the rule as shown. The rule rests steadily on the supports. Which row is correct? The total moment about M and the total moment about N. Since it is stationary, that is equilibrium. So the total moment should be 0 about any point. So the answer is D. Question 6 says the diagram shows an object moving at constant speed in a circular path in the direction shown. A force acts on the object to keep it in the circular path. In which labeled direction does the force act? So the resultant force should be towards the center for any object moving in a circular motion with constant speed. Question 7 says a trolley of mass 4 kilograms traveling with a velocity 4 meters per second collides with a trolley of mass 2 kilograms traveling with a velocity of 2 meters per second in the same direction. After the collision, the velocity of the 4 kilogram trolley is reduced to 3 meters per second. What is the velocity of the 2 kilogram trolley? So we can use the equation of conservation of momentum. m1u1 plus m2u2 equals m1v1 plus m2v2. Then we substitute by the numbers. M1 is 4, u1 is 4, plus, since it's in the same direction, m2 is 2, u2 is 2, m1 still 4, v1 is 3, m2 is 2, v2 is required in the question. So we move this bracket to the other side by subtraction, then we divide by 2. So we have 16 plus 4 minus 12, then we divide that by 2. That gives an answer of 4 meters per second, so the answer is B. Question 8 says an object falls towards the Earth's surface. What happens to the gravitational potential energy and to the kinetic energy? So as height decreases, the gravitational potential energy decreases and is converted to kinetic energy, so kinetic energy must increase. So the answer is B. We also said that the kinetic energy increases because there was no mention of any air resistance or friction. If there were any resistance or friction with motion, so some of the gravitational potential energy would have been converted to thermal energy, but it was not mentioned in the question. Question 9 says a boy takes 0.60 seconds to lift a block of mass 0.60 kilograms from the top of a disc and place it on a shelf. The top of the desk is 0.80 meters above the floor, and the shelf is 1.7 meters above the floor. The gravitational field strength is 10 newtons per kilogram. So here we use G as 10. What is the power developed by the boy? So power is equal to work over time, or the change in energy. Here it is potential energy over time. So we can calculate it as mg delta H over time. So the mass was 0.6, G is 10 in this question. The change in height, we calculate 1.7 minus 0.8. Then we divide by the time, which is 0.6 seconds. This gives an answer of 9 watts, so the answer is C. Question 10 says a mass is lifted from rest on the ground to Y. There is no air resistance. P is the increase in gravitational potential energy. Q is the kinetic energy at Y, and it was at rest, so there was an increase in GPE and increase in kinetic energy. Which expression is equal to the mechanical work done? So the work done must supply the gravitational potential energy and the kinetic energy gained. So we add these energies together to calculate the work done. So the answer is A. Question 11 says the diagram shows a tank containing seawater. The density of the seawater is 1020 kilograms per meter cubed. What is the pressure at point B relative to the atmospheric pressure? So we have a depth of 8 minus 0.60. We must recognize that this is centimeters, not meters. So the depth is 7.4 meters. And we can calculate the pressure as rho GH due to the liquid alone. So the density is 1020 multiplied by 9.8. Then we multiply it by 7.4. This gives an answer of 73,970.4 Pascal. The closest one would be 75. In this year, G was taken as 10 meters per second squared, or Newton per kilogram, not 9.8. That's why the answer is different, but we choose the closest one anyway. Question 12 says the pressure of a fixed mass of gas in a cylinder is measured. The volume of the gas in the cylinder is slowly decreased. The temperature of the gas does not change. Which graph best shows the pressure, how the pressure changes during this process? So the pressure is not constant. As volume decreases, pressure increases, but the pressure does not start from zero, so also B is wrong. Pressure starts from a low point and ends at a higher point, so the answer is C. Question 13 says wet clothes are hanging outside to dry. What are the best conditions for the clothes to dry most quickly? So we need high speed of wind and high temperature, so the answer is A. Question 14 is about thermometers, so you can skip this question for the new syllabus. It says which change in the design of a liquid and glass thermometer makes it more sensitive? A larger liquid reservoir, yes, that would increase the amount of expansion. Longer tube, no, that increases the range. A smaller liquid reservoir, that decreases sensitivity. A wider tube, no, that decreases sensitivity. It should be narrower, so the answer is A. Question 15 includes latent heat, which was removed from the syllabus, so you can skip this question too. It says a scientist is determining the specific latent heat of vaporization of a liquid. He puts the liquid in a vacuum flask and heats it with a 100-watt heater. The mass of the liquid in the vacuum flask when it starts to boil is 300 grams. He continues to heat the liquid for a further 12 minutes, after which the mass of the remaining liquid is 100 grams. So the actual mass vaporized or boiled is 200 grams. What is the specific latent heat of vaporization of the liquid? So we can use the equation Q equals mL, or L is equal to Q over M. And Q is the thermal energy. We can calculate it by multiplying the power and time, then divide by mass. So we have 100 watts and the time is 12 minutes multiplied by 60 to convert it to seconds. Then we divide by the mass, which is 200. The answer is 360 joules per gram, but all the answers here have units joule per kilogram except this one, and it's not equal to the number we calculated. So if 1 gram takes 360 joules, 1000 grams, which is 1 kilogram, would take 1000 times greater. So the answer is D, 360,000 joules per kilogram. Question 16 says, which piece of equipment is designed to produce a type of electromagnetic wave? Electric fire. It can produce infrared radiation because fire generates heat, and heat is sent out as radiation. Electric generator, no, it produces voltage, not waves. Electric motor produces motion, not waves. Electromagnet, it produces force or kinetic energy, not waves. So the answer is A. Question 17 says, a sound wave travels from air into water. Which row describes what happens to the frequency? Frequency does not change, so it stays the same. And the wavelength of the wave. So wavelength increases and decreases with speed. And moving from air to water, in light, the speed decreases, but in sound, the speed increases. So the wavelength should increase. So the answer is D. Question 18 says, a diagram shows plain water waves in a ripple tank passing through a gap between two barriers and spreading out. Which name is given to this effect? It's called diffraction. So the answer is A. Question 19 says, a ray of light travels from air into a material as shown. What is the refractive index of the material? So the refractive index of a medium is equal to sine the angle of air divided by the sine of the angle in the medium. So we have here sine 90 minus 40, which is 50, divided by sine 27. We need the angles from the normal, not from the surface. So this is 50 and 27. By calculating this, it's almost 1.68, which is approximately 1.7. So the answer is C. Question 20 says, a diagram shows an object in front of a plane mirror. At which labeled position is the image of the object formed? So this is the object. The image is right in front of the object and at the same distance. So the answer is B. Question 21 says, the angle between an incident ray and the surface of a plane mirror reflecting the ray is 70 degrees. What is the angle of incidence? So if the angle is 70 from the surface, it's 20 from the normal, 90 minus 70. So the answer is A. Question 22 says, the diagram shows the air molecules in part of a sound wave at a particular moment in time. Which statement is not correct? Earlier there was a compression at X. Yes, it's now a rarefaction. Later there will be a rarefaction at X. Also yes, since the wave is moving. This part of the wave is traveling horizontally across the page. This is correct. This part of the wave is traveling towards the top of the page. No. Compression, rarefaction, compression, and rarefaction, that gives actually the direction of the wave. So the wave is moving to the right. So D is the answer. It's not correct. Question 23 says, an object is reflected in a plane mirror. Which description of image is correct? It is not diminished nor enlarged. It's the same size. And it is virtual, not real. So the answer is D. Question 24 says, a 100-meter race is started by firing a gun. The gun makes a bang and a puff of smoke at the same time. When does the finishing judge see the smoke and when does he hear the bang? Seeing means depending on light. That's almost immediately because light travels much faster than sound. And hear the bang, that's much slower, so about 0.3 seconds. So the answer is B. Question 25 says, two magnets X and Y are placed end to end on a bench. The diagram shows a magnetic field pattern between the poles of the magnets. So if the field going out of a pole, that's an N pole, and towards another pole, that's an S pole. Which row shows the direction of the forces exerted on X and Y by the magnetic field? So opposite poles attract, so N would move to the right and S would move to the left. So on X, that's to the right. On Y, that's to the left. So the answer is B. Question 26 says, a diagram shows a circuit used to control the potential difference across a lamp. The variable resistor is adjusted until the potential difference of the lamp is 6 volts and the current in the lamp is 0.5 ampere. So we have V and we have I. What is the resistance of the lamp? Resistance is equal to potential difference divided by current. So we divide 6 by 0.5. That gives an answer of 12 ohms. So the answer is D. Question 27 says a charge Q flows through time t through a resistor of resistance R. Which equation gives the current in the resistor? The defining equation for current is charge divided by time, so the answer is C. Question 28 says a plastic rod is rubbed with a dry woolen cloth. The rod becomes positively charged. Which statement is correct? Electrons move from the cloth to the rod. No, electrons should move from the rod to the cloth. Since the rod becomes positively charged, that means it lost electrons, so the answer is B. Question 29 says which diagram shows a graph of current against voltage for a filament lamp? We should be able to memorize this, that the voltage current for a lamp starts from the origin and then curves towards the voltage axis, since resistance increases as current increases in a lamp due to temperature rise. As temperature increases, the resistance of the lamp or the filament increases. Question 30 says each potential divider is placed in a circuit with a power supply. Which potential divider makes the potential difference across component Y increase when the light intensity increases? So when light increases, the resistance of an LDR decreases. So here resistance decreases, so voltage decreases, and the voltage across Y increases. So this is the answer. Question 31 says diagram 1 is a circuit diagram showing an AC power supply connected to 4 diodes and a resistor. Diagram 2 shows the output voltage of the power supply. Which graph correctly shows the voltage time curve across the resistor R? So technically it should be a full wave rectification. It should be B, but just in case we check if the current always moves in the same direction in R. So if this is the positive terminal and this is a negative terminal, the current can move through this diode and goes through the resistor downwards, and it can go back through this diode and returns to the power supply. If we reverse the polarity, the current goes down here and it cannot go through the bottom diode. It must go through this diode, and then goes up there, then goes also down. So it's the same, but returning, it can go through this loop to reach the negative side. So still same direction, so it's a full wave rectification, so the answer is B. Question 32 says which diagram shows a circuit symbol for a fuse? A fuse is like a resistor, but the whole connection is going through the rectangle, so the answer is D. Question 33 is about logic gates, so you can skip this one for the new syllabus. It says a diagram represents an alarm system using a logic gate, temperature sensor, smoke sensor, and the logic gate, and then a siren. The data for the system is shown. Temperature sensor gives 0 when cold and 1 when hot. Smoke detector gives 0 when there is no smoke and 1 when there is smoke. Siren sounds on when the output of the logic gate is 1. The siren sounds when there is any indication of a fire. Any indication means OR, so we need an OR gate, so the answer is B. Question 34 says 4 small compasses are placed around the solenoid. A current is now switched on in the solenoid. When the current is in the solenoid, the magnetic field is like this, and the compasses should point as tangents to the magnetic field lines. So it's not A nor B, since these compasses are not pointing as tangents to these lines. And the magnetic field should be pointing in the same direction around the coil. So it should be pointing either away from one side and going towards the other side, or in the opposite direction. So these compasses should be pointing in the same direction, so the answer is D. Question 35 says transformers are used in the transmission of electrical power to houses. Which type of transformer is used at the power station prior to connection to the power lines, and which type is used prior to delivery to the houses? So at the power station, we use a step-up transformer to decrease the current and decrease energy losses. Then we step down the voltage to make it safer before the houses. So the answer is C. Question 36 says a diagram shows an AC generator rotating in a clockwise direction. What are the names of parts 1 and 2? So 1 is a brush and 2 is a slip ring. So the answer is A. Question 37 says a thin metal foil is placed in a vacuum. Alpha particles are fired at the foil and most go straight through. A very small portion of the alpha particles are deflected through large angles. What does this provide evidence for? Alpha particles are very small. That's not part of the conclusions of the experiment. There are negative electrons. That was not in the conclusions of the experiment. There is a tiny nucleus. Yes. That's why some of the alpha particles got deflected, because they reach the nucleus. There are neutrons that also cannot be determined using these results. So the answer is C. Question 38 says thorium-230 is represented by the symbol Th23090. This isotope is radioactive and decays to radium by emitting alpha particles. So alpha particles decreases this number by 4 and the proton number by 2. So 90 should be 88 and 230 should be 226. So the answer is A. Question 39 says the diagram shows a piece of apparatus used to determine the nature of the emissions from a radioactive source. The absorbers can be raised out of or lowered into the path of the radiation from the source to the detector. The apparatus is evacuated. The table gives sets of results for a particular radioactive source. When there is no obstruction, the reading is 350. When a thin paper is lowered, reading still 350, so no alpha particles. It decreases when we use 1 millimeter of aluminium, and it decreases again when we use lead. So beta particles and gamma rays are present. So beta and gamma rays only. So the answer is C. Question 40 says the graph shows the measured count rate for radiation from a source containing a radioactive isotope. The detector is in a laboratory with no shielding from background radiation. What is the measured count rate after a time of 1 half-life? So we need to correct for background. So we take the first reading, then we subtract the background, which is Y. This level is a background. Then we divide that by 2. Then to know the final reading, we need to add the background again. Then we look at the answers. It's not the same, so we need to simplify this even more. If we use 2 not as a common denominator, we can split this into x over 2 minus y over 2. Then we add y. If we take these two, we can calculate y minus y over 2. That gives actually y over 2, positive y over 2. Taking this and this, that gives a final answer of x over 2 plus y over 2. So the answer is D, 2 taken as a common denominator. This last part was actually about mathematics, not about physics. This was the extent of the physics in this question. Then the rest was calculations, but we reached the final answer anyway. So this was the end of the exam. I hope you found this video useful to you and enjoyed it, and I will see you in another video.